Hey, teacher, math students, welcome to Proportionality and Graphs. So it says use the information below to create a table and determine the constant of proportionality. So a bike rider cycles 18 miles in 1 hour. So our x value is going to be hours, our total miles is going to be y. And when I input 1 hour, I get 18 hours. When I input 2 hours, I get 36 hours. 36 miles, right? When I input 3 hours, I get 54. So as you can see, our constant of proportionality is just basically the number of hours times 18, right? Times 18, times 18, times 18. So you can fill in the rest of this table here. I'll do the last one, I'll do 5 here. You can get 6 and 7. But our constant of proportionality is going to be 18 miles. Our ordered pair is simply going to be 1, 18, 2, 36, 3, 54, 4, 72, 5, 90. And then our equation for this graph is just going to be simply y equals 18x. So when we're creating our axis, we want to go ahead and say, hey, our x-axis, our horizontal axis, that's going to be in hours, right? And each one's going to represent an hour. So 1, 2, 3, 4, 5, 6, 7. And our y-axis, that's going to be in miles. So you kind of write that sideways. And we know that that's going to go up by 18. So 18, 36, 54, 72, 90, 108, and 126. So basically we're going to go ahead and say, hey, my point was 1, 18. There's a point right there. And it was 2, 36, 3, 54, 4, 72, 5, 90, 6, 108, and 7 over 126. And remember, just like I was showing you earlier on this week, a proportional graph will have a constant rate and will get you a straight line. So there's your graph right there. So if we take a look at the two graphs below, let's take a look at our observations here. So the characteristics of proportional graphs, obviously we have a straight graph. What does a straight graph mean? It means it's got a constant rate, whether it's positive going up like this or negative going down, and it goes through the origin, right? Where the origin is the point 0, 0, right? If we look at non-proportional graphs, we might see might not be straight. Like this first one is straight, but this second one is not straight, meaning it's not necessarily constant. Right? And look, they both don't go through the origin, right? See that 0, 0 point right there? It's empty, right? So do not go through the origin, meaning they have a different starting point than proportional graphs that do go through the origin, 0, 0. Right? Let's go ahead and flip over to the back. So proportional relationships are linear, and that is a fancy math word for straight, and pass through the origin, and we know the origin is 0, 0. So we're going to take a look at these graphs, and we're going to say, are they proportional or not? So if I got x is 1 and y is 1, I'd go over, I'd say 1, 1 right there, and then 2, 3, I'd go to 2, and then go up to 3 right here, and then go 3, 5, I'd go to 3, and then up to 5 right here. I'd go 4, 7. I'd go, in fact, I'm going to zoom in for you guys so you guys can see this a little bit better. There we go. 4, 7, which is right here, and then 5, 9, which would be right there. So notice if I draw a straight line through this, 5, 9 would actually be a little bit higher than that. Straight line, does it go through the origin? Yes, it does, right? Actually, no, it doesn't. See how it actually kind of misses the origin right there? So not proportional. Why is it not proportional? Does not go through the origin. Right? Let's take a look at another one. So we've got -3, -6. So move left 3, 1, 2, 3, down 6, 1, 2, 3, 4, 5, 6. Put your dot right there. -1, 2, move left 1, down 2. 1, 2, move right 1, up 2. 3, 6, right 3, up 1, 2, 3, 4, 5, 6. And 5, 10, you'd move right 1, 2, 3, 4, 5, but you can't get up to 10. It's up here someplace, right? So now again, you draw a straight line through these points, right? And you ask yourself, is it proportional? The two ideas is yes, it's proportional. Why? One, it's a straight linear line, right? And two, it passes through the origin. All right, again, so that idea of linear, in order to be a linear line, it has to be straight, and hopefully yours is a little straighter than mine, use a ruler, and it passes through the origin, and really mine should have drawn a little bit better there, but it goes through that origin. This one was a little off because it did not. Okay, so let's take a look at some test questions that you might see. So number 4 says the number of feet in a yard can be represented by a graph. Which of the following graphs best represents y, the number of feet in x yards? So remember, there are 3 feet in 1 yard, right? So if x is yards and y is feet, you should have a point that's 1, 3, right? So go here. Do I have a point 1, 3? No. See you later. Do I have a point 1, 3 here? Yes, I do. Right there. Do I have a point 1, 3 here? No. It even starts at 3, so no. Do I have a point 1, 3? I have a point 1, 6. So that can't be it. So B is your answer. You got a linear line. It goes through 0, 0. And remember, it was 3 feet for every 1 yard. They said X value was going to be the yards, so 1 yard. That goes in the X part right there. And the Y value was going to be the number of feet. So 3 goes in the Y spot right there. All right. And number 5, I'm going to go ahead and have you try and do on your own.